Hey, this is Mr. A, and I want to give a real quick lesson on solutions, colloids, and suspensions. It's easy to get those confused, but what I want you to remember is that it's all about the particle size. Solutions have these invisible particles. The particles are so small you can't see them, even with a microscope. Colloids have small particles in them, but you can see them with a microscope. And suspensions, that has particles in it that you can practically see. Now, I'm really generalizing here, but I think this is really the easiest way for you to get your head around what solutions, colloids, and suspensions are. Think about the particle size. Previously, when we've talked about this, it's been helpful for me to say in a suspension, the particles are so large, those particles are so large that they fall out. And the go-to example has always been the sample of pond water that I have in my classroom, that if someone shakes it up, then yes, it's all cloudy and murky, but after a while it will all settle down. And my go-to example for a solution has been like Coca-Cola. Now let's remember that it's going to have to be flat Coca-Cola, because if there's any fizz in it, well then it's not really a homogeneous solution. If you can see bubbles and it's heterogeneous, and it's not really homogeneous, and if it can't be a solution unless it's homogeneous. All right, just assume that Coca-Cola is flat, there's no bubbles in it, and you can't see the sugar, you can't see the caramel coloring, well, you can see the color, but you can't see the things that are making up the coloring. You can't see the secret formula in the Coca-Cola. Maybe it's better to think about the example of salt water. You put salt in water, you stir it up, the salt, it gets dissolved in the water. You can't see the salt floating around in the water anymore. That is a solution. The particles are so small, they're definitely not going to fall out. You can't even see them. Then we have this thing in the middle, which is a colloid. It says, yes, we've got some particles. They're not heavy enough to fall out, so they just kind of float around. Fog and smoke, those are the examples that we've used on it. But people ask me, well, what are some other examples? So if you do a little digging, you could, well, if you Google examples of a colloid, you'll come up with gelatin and ink and things like that. Maybe it's a little bit easier, the more examples that you get in your head, the more easy it is to think about it. But really, remember, it's all about the particle size. Let me take that one step further, the particle size idea, a little bit further, and talk about the scattering of light. If you remember from our studies, the colloids are the only ones that scatter light. Let me try to give you an image to put in your head. With solutions, these particles are so small, the light waves don't even see them. They go right by. And I'm going to draw a light wave as a squiggly line. So the light waves go right by. They don't even notice that the particle is there. With a suspension, let me go to the other extreme. Those particles are so big, they're going to get hit by the light beam and they're going to be absorbed. So the light beam is going to come, zzz, bang, and it's going to get absorbed in that big particle. Now the things that make colloids scatter light is that they're in this in-between size. The light wave sees it, but they're not big enough to be absorbed by it, so they scatter. You can think of it kind of like bending. So the light wave comes along, zzz, whoa, what was that, right? And it kind of goes off in another direction. If the left light beams are going in all different directions, that's what you see, and that's what we mean by the scattering of light. So colloids scatter light. But they scatter light because they're just the right size. So remember, when you're talking about solutions, colloids, and suspensions, it's all about the particle size.